Remember on the very first test that we took, I gave you a question where you had like 6 limit things, clues, and you had to use those clues to draw a graph? Yes. So now instead of it being limits, how about we give you some information about the derivatives? The first derivative and the second derivative, and ask you to sketch a graph that would meet those criteria. It's not nearly as hard as it looks, but you've got to be able to translate it. Yeah, in math, a lot of it is translation, I think. When you see that, you don't need to say f prime of x is greater than 0 when x is less than -1. I mean, I know that's what it is, but slope. So when you see this right here, it's exactly what Matt said. What did you say?
Slope is positive when x is less than -1.
And then this would be, same thing. Slope is positive. And this would be slope is negative. What do you think when you see second derivative?
The slope.
Exactly. When f double prime is less than 0, is that concave up or concave down? Concave down. And this is concave up. Less than 0 means negative. That's important. I'm assuming we got that. So they're telling us we have a graph where we have positive slope and negative slopes and concave ups and concave downs. It's just a matter of you sketching a graph that meets those criteria. So it really is pretty easy once you translate it. So we need positive slope when x is less than -1. So here's x is -1. Positive slope. Okay, so we're going uphill. Now you might not draw that yet, because I haven't worried about the concavity. But okay, we got positive slope. And we also, when x is greater than 3, so I'm going to go over here to x is greater than 3, I need to have positive slope. So I'll start it down here and have positive slope. And then, between -1 and 3, that's this clue right here, I have negative slope. Does the graph I've drawn fit the first 3 clues? Now all I've got to do is get the concavity. Concavity deals with curves, not straight lines. So when you see these straight lines, that's not concave up or concave down. That's just a mess. So, concave down. Concave down when we're less than 2. So right here's where 2's at. I need to go up and then come down. Concave down. Smooth out that curve to make it frowning until you get to 2. Now, doesn't this mean that 2 is my inflection point?
Yes.
It's where I change concavity. It's important to know that. It's important to be able to look at all that and say x equals 2 is an inflection point. It's also important to know that inflection points aren't the same thing as max and mins. I'm still going to be going down after this, aren't I? 2 is my inflection point, but I have negative slope until I reach 3. So I've got to keep going down until I reach 3, but then I've got to go back up. You see how right here at x equals 2 is where I change. If you were to look on the left side of the graph, I'm frowning. On the right side of the graph, I'm smiling. I only drew this slanted line in here just so you can see it. But the blue is my final graph without the slash in it. There's a graph that meets all 5 criteria. So, conceptually, we've seen some things that are a little tough to kind of visualize, this whole concavity thing, and then we've seen the problems take up a lot of paper, a lot of places you can make mistakes, and we've only done an easy example. Welcome to calculus. Now, your assignment, even though we've got one more example to do tomorrow that's a little harder, you can actually start this assignment. And I would suggest that you start it tonight, that way you can see if you need to ask questions. But after I show you the one example tomorrow, then you'll get to work in class on it. And if you have some